Kia ora koutou. This is the first video that I'm doing for this year's Level 3 Calculus exams. Question 3E from complex numbers. So we're told that x plus 1 over x is equal to p, and we have to find the value of x cubed plus 1 over x cubed. P is a real constant, and our answer is going to be in terms of p. So if we look at it for a minute, if you're doing scholarship calculus with me, you'll notice that this question is one that's come up in quite a few different forms in those classes. So if you've been in those classes, you probably will find this question really easy. So I'm going to go pretty slowly in this video for people who are not doing scholarship calc. I guess the thing to notice here is we've got cubey stuff, right? And here we've got x stuff. So let's just think about where we can start from. We've got x plus 1 over x is equal to p. And to get a cube in there, we're going to cube both sides. Right? And if I do the same thing to both sides, right back from year 9, nothing really is going to go wrong. So what we're hoping is that when we expand this, we get something that doesn't have a whole lot of leftover x stuff in it. And that's what turns out to happen. So if you're confident with doing expansions using Pascal's triangle, then the fast way to do that expansion is to know that we're going to have x cubed, so the first term, cubed, plus 3 lots of this one squared times 1 over x, and then 3 lots of this one to the power of 1 and this one squared. I am going to do this more slowly for people that haven't seen it this way before, and then the last term will be 1 over x cubed, and that gives me p cubed. Let's just get rid of the Pascal's triangle coefficients in the way. Now, cleaning this up, you can see that where we want to get to is the x cubed plus 1 over x cubed, and we've got that sitting in here nicely. We've got x cubed here and 1 over x cubed here, and then we've got this extra stuff. So let's write it as x cubed plus 1 over x cubed, and now I've got plus 3x plus 3 over x equals p cubed. Now we have x cubed plus 1 over x cubed plus 3 times x plus 1 over x gives me p cubed. And we know that that's what p was given to us as right back at the start. So overall we have x cubed plus 1 over x cubed is equal to p cubed minus 3p. And that's what we had to show. Now I'm just going to do that expansion slowly in case you're not confident with doing binomial expansions. We've got x plus 1 over x plus x plus 1 over x. Sorry about that noise, guys. It's just the curtain's getting pulled. Right, so I'm going to expand the back ones first. Got x plus 1 over x times x squared plus this, which gives me 1, this, which gives me 1, and the last term, which gives me 1 over x squared. And off we go again. I'm going to plonk this into place value rows, so we get x cubed plus these two together, 2x here plus x over x squared. There's going to be quite a bit of cleaning up doing it this way, right? Now I'm going to go these ones. So I'm doing this one here, 1 over x times x squared plus 1 over x times 2, these, plus 1 over x cubed. And when we clean all of that up, obviously we should get the same as what we got before, but I'll go slowly. So we get plus 2x plus 1 over x plus another x plus another 2 over x from this one here plus 1 over x cubed. And that gives me, when I add up my like terms, I get x squared plus, where have we gone wrong? Something weird's happened. Hang on. X squared plus, oh no, that's right, plus 3x plus 3 over x plus 1 over x cubed. So those are little extra steps. I think, yeah, it's not a show that question, so it's absolutely fine if you are confident to have gone straight from here to here. And I think even if it were to show that question, that should be okay. All right, so that's the first one done, a nice short video. The next couple of excellence questions are definitely longer, but also, I think, reasonably straightforward and similar to previous year's papers. Thanks for watching, and email me if there are any particular questions in the rest of the paper that you'd like done soon.